Assalamu alaikum wa rahmatullahi wa barakatuh. Friends, welcome back to my channel. When we see IPM drive, any half bridge, full bridge drive, we see a capacitor that is connected across gate to source pin of the MOSFET or IGBT for the high side IGBT. Low side IGBT don't have that capacitor. That is called bootstrap capacitor. How it works and why any high side IGBT need bootstrap capacitor, we will discuss in detail. Let's start. It is three-phase drive IPM, Intelligent Power Module, UVW. Three output stages are here. In this section, U section, pin 7 and 8, there is a capacitor, the first one. Second capacitor between pin number 15 and 16. Third capacitor in these two pins. Pin number may be different depending on the type of IPM. If we are discussing any bridging topology, that time the high side IGBT is connected with a capacitor. Why we need bootstrap capacitors? If you remember push-pull topology, we have a center tape winding that is connected to positive voltage. In the second end of the winding, we have any transistor, IGBT, MOSFET that is driving this portion of the winding. And in the second side, another transistor, IGBT, MOSFET is connected. Any switching device. This end is connected to ground, this end is connected to ground. We know when we want to charge its gate, either it is IGBT, MOSFET, or we are discussing transistor, emitter to base in case of MOSFET, source to gate in case of IGBT, emitter to gate, we will apply voltage here. And here. Both emitters are at same voltage level. VGS, voltage gate to source. I apply 10 volt pulse to this transistor, it will turn on. If I will apply here, this will turn on. At that time, it will switch this ground potential to the winding and this section will work. Current will flow in this direction. If this transistor is turned on, the same ground potential is applied. Current will flow here in this section. If we want to discharge it, a discharge resistor is connected between these 2 points. This is push-pull. But when we say bridging technology, bridging topology, any transistor, MOSFET, IGBT is connected here in this section, and second IGBT is connected here. Two pairs, this pair, and load is connected in between these two junctions. Transistors will turn on in cross, either these two or these two. If we discuss IPM, at that time 3 pairs will be used. That time the signal will a combination of 6 signals, but now we will say we have one drive here, second drive here. If we compare with this one, this end is connected to ground, this end is positive. We can say 300 volt, 330 volt. If we apply a signal here between ground to this gate pin, VGS, it will work normally. This will normally. When it will turn on, it will switch this ground potential to this winding, and this will switch, it will provide positive potential to this winding. Now I will draw equivalent circuit. This one and this one, these two are turned on now. Now if we check here, I am providing 330 volt DC. This end is ground. I have an external power supply, 12 volt, 15 volt, 18 volt. We provided that pulse between these 2 points for this transistor. It will turn on. When it will turn on, we can say in the datasheet it says 1.4 volt will drop or 1 volt will drop here. So winding this end, 330 minus 1.4, so it will float 1.4 volt here, then the ground level. But if we check this point, 330, it is also dropping 1.4 volt. 330 minus 1.4 volt, so this point will approximately 328.6 volt. So it is floating point. It is higher than the ground level, so we cannot use any driving IC between this point to this point. When it is switching from here, this was turned off, it was not working, so current will flow from this IGBT to load to the ground. It switched. Okay, when we want to discharge it, a discharge resistor will come here and it will discharge it. But if we will connect here, this point is now floating at 328.6 volt with the reference to this ground. So any driver stage, if it will float, it will damage this IGBT. Let's see some examples of these driver ICs, because in the IPM there is logical drive section, high load drive, IGBT, or MOSFET high load drive section. That is here. There are different ICs. If we see this LF2101, it is 8-pin IC. We apply VCC voltage to VCC pin, common to its common pin, and this common is connected to DC rail common. Here we have up to 600 volt DC. But if we come here, high in and low in, these are 5 volt pulses. In some cases 3.3 volt pulses, but here 5 volt pulses. 15 volt power supply is connected here. When we combine grounds of 2 different power supplies, so that will use that reference point. So this pin is now at 15 volt. If we are providing 15 volt with reference to this ground, and this point is 600 volt with reference to this point. In the second side, LO, low side output drive, high side output drive, HO. Then there is VS, source pin, that is connected to common pin, and this one VB, bootstrap voltage. Here is a capacitor connected between VS pin and VB pin, and this power supply there is a resistor, diode that are coming to VB pin. So if we apply any voltage here, positive voltage at this point, this positive voltage will reach to this resistor and this will reach to VB pin, bootstrap pin. Why we use this capacitor? Here is its detailed diagram. Supply voltage, under voltage detector. Now if we check, these voltage are reaching to this NOR gate. These voltage are coming here, supply voltage, and low in drive is reaching here. So it will drive here, and this pin is connected to VCC pin, that is same this pin. That means if we apply this voltage and ground here at common point, our this drive section will work normally. If this is on, it will provide common at low out. If it is giving signal, that time this will turn on, it will provide positive VCC voltage. So we will receive pulse here. But this section, its high side driver stage, totem pole stage is connected to VB pin, bootstrap pin. For that purpose we need a resistor, a diode to this point. If we compare this side, it is connected to ground, but there is no ground here. It is connected to source pin. That means we need an external source to provide conduction to this stage. But now if we check this point, when this is on, it will reach at 1.4 volt. It will float. But if we will turn on this one, it will reach up to 328 volt, 328.6 volt due to 1.4 volt drop from this transistor. So we need a stable power supply, because any power supply we need positive and its return path. When we connect a diode here, it will isolate this pin from this one, because there is no return path. Voltage coming from here are pumped to this pin. When this transistor is turned on, ground to this point, and if we connect a capacitor here between these two points, that is this point, we are not connecting capacitor between this voltage and ground point. We are connecting between this supply, that is 15 volt supply, and ground. At that time this will charge at same VCC voltage. VCC voltage minus this resistor voltage minus this capacitor voltage minus 1.4 volt. If we are providing 15 volt power supply here, 15 minus voltage drop across these two components and this transistor, might be this capacitor will obtain 13 volt, 13.5 volt, like that. That means we need to turn on this transistor. At that time this capacitor will charge. Yes, here if we want to charge this capacitor, because there is no return path from anywhere at this point, we need to turn on this transistor, this MOSFET, to provide ground potential to this capacitor, because a return path for this power supply and this side is common. So if you will turn on this switch, this ground potential will reach here and positive voltage are reaching to this capacitor, positive side. That time these voltage minus 1.4 volt, 1 volt drop of this IGBT MOSFET will reach here. So this capacitor will charge. When it is charged, now we have a power supply across this driver stage. Same here, VCC and ground. But now VCC voltage are reaching, isolated VCC voltage are reaching here, and we created a virtual ground to provide source voltage at this pin. So now we have positive voltage and virtual ground. In practical that ground is not available, but we provided a charging point from this MOSFET. So now we have voltage to drive this HO pin, high side output pin. When it will turn on, at that time positive voltage level of this capacitor will reach to drive the IGBT here. When it will need to turn off, it will drive this MOSFET, this IGBT. So source voltage that are here, physically it is floating at 328.4 volt, but for this driver stage we have external capacitor. So current will flow from here to charge and to discharge from here. Charging path from here, we can say this bootstrap capacitor will charge from this VCC voltage, ground from this side, because low voltage power supply and DC rail ground are common. When it will charge, its positive level will use to turn on this upper side transistor for creating high side pulse, this one. When it is on, how much time it will remain on, and then it will turn off. When it want to turn off, at that time capacitor low side voltage, this side, will be used to provide this low level. So this capacitor is basically used to turn on and turn off high side IGBTs. When these two will off, this and this both will turn on. When this will turn on, it will provide charging voltage for bootstrap of this capacitor. When this will turn on, it will provide charging voltage to its high side IGBT. Bootstrap capacitor will be charged at each half cycle, switching cycle for low side IGBT. Half cycle it will turn on and it will charge the capacitor for low side. When it will turn on, it will discharge this capacitor. So in complete one cycle, high low, capacitor will be charged and discharged. 2101 IC, the same circuit. 2102 IR2102, the same bootstrap capacitor is here. VCC capacitor, bootstrap. So VCC voltage are used to turn on low side IGBT. Bootstrap voltage are created to turn on high side IGBT. This section will receive voltage from VCC pin, and this will use bootstrap voltage and source voltage, VS voltage, to operate this section. Same here, UC27714, it is also the same circuit. MCP14700. If we see this low side drive, it will provide charging voltage to this capacitor, bootstrap capacitor, and when it will turn off, these voltage will be used to turn on this IGBT and it will drive this load. MCP14700 IC is used to drive 3-phase BLDC motor drive circuits, 6 IGBTs, 2 IGBTs, high and low, will be controlled by one IC, the second two will second IC, third will third IC. VCC voltage are applied here when low side pulse is provided at this point. Its driver stage is connected to ground. VCC is provided here. At that time, this VCC capacitor will provide VGS voltage to this MOSFET, gate to emitter voltage for IGBT. So charging and discharging voltage will be used from this pin, VCC pin. At same time, this ground potential is provided to this bootstrap capacitor. At that time, when this low side is turned on, this will turn off. So it will provide charging voltage to bootstrap pin. When this pulse will off, low side, high side will on, what will happen? It will turn on this logic. At that time, these positive voltage will be used to turn on this IGBT MOSFET. Same time, when the pulse will off, these capacitor voltage will be provided to discharge the gate. When we are using standalone IC, we need to connect an IGBT MOSFET. At that time, we need to know what is the gate capacitance, what is the switching frequency, and what is the duty cycle. Why we need? Because bootstrap capacitor will be used to charge and discharge the capacitance of the gate. If gate capacitance is more and more, we need large capacitor. Then the time, frequency and duty cycle. If we are using low frequency, we need to connect large capacitor because we are consuming the current here at this pin. So this capacitor will discharge in high side IGBT switching. For that purpose, a careful calculation is done to provide a perfect capacitance. But when we are discussing IPM, most of the IPM, they know what is the capacitance of their IGBT. So bootstrap diode and bootstrap resistor is connected. We need to connect just only external bootstrap capacitor and one coupling capacitor to decrease the switching noises. So this bootstrap capacitor will charge at low side IGBT switching, and it will provide charging voltage to high side IGBT. LTC 4446. This IC is also same. 2 input pulses, supply pin, common pin. These are input side. In output side, source pin, high side drive, low side drive, bootstrap capacitor pin. 8 pin IC. Some ICs are 14 pin like this. VDD pin, high, low, VSS, that is ground pin. Then some ICs have enable pin, common is also ground, VSS also ground, HO, high side IGBT drive, LO, low side IGBT drive, HS, high side source pin, HB, high side bootstrap voltage. So either it is using 14 pin IC or either it is using 8 pin IC. It will provide switching drive to high and low side IGBT. If you enjoyed this video, hit the like button. If you have any question, please write in the comments. Thanks for watching. Assalamu alaikum wa rahmatullahi wa barakatuh.